Welcome to this short presentation on the process of importing content into OntoServer, principally via OntoServer's syndication capabilities. This presentation will cover a short overview of the various content types supported by OntoServer and a high-level overview of OntoServer's syndication capabilities to provide some context. Then the presentation will move on to explain how to import content into OntoServer, create indexes for SNOMED-CT and LOINC, import those indexes into OntoServer, and finally remove indexes from OntoServer. OntoServer is a FHIR terminology server and supports the main FHIR terminology resources: code system, concept map, value set, and naming system. OntoServer also supports bundle and structure definition resources to provide features related to validation and terminology binding. However, for larger and complex code systems, specifically SNOMED-CT editions and LOINC, which have detailed specifications in FHIR, OntoServer has a special process to create binary indexes it uses to enable advanced functionality supported by these rich code systems. OntoServer can build these indexes from SNOMED-CT and LOINC code system sources. However, as this is a resource-intensive process, OntoServer also supports sharing these indexes via its syndication capabilities to minimize the number of OntoServer users who need to perform this resource-intensive task. Content can be added to OntoServer through its FHIR API and its inbuilt syndication client. The FHIR API is principally used to author content and is an API that can be used to push FHIR resources into OntoServer. However, the syndication API is the main topic of this presentation, used to pull content into the server. This can be used to pull FHIR resources and binary indexes from pre-configured sources using a syndication client that's built into OntoServer. The pre-configured upstream syndication sources are usually OntoServer instances or Atomio instances, which is a CSIRO-supplied standalone syndication server. However, a syndication source can be as simple as a conformant Atom feed on a web server or file system. These upstream syndication sources are considered authoritative and may only be configured by an administrator. This syndication mechanism is also the only way to import binary indexes built by another OntoServer instance. Moving on to how to import using upstream syndication resources. As just described, OntoServer must be configured with upstream syndication sources by an administrator. OntoServer can then be instructed to pull selected items or the entire content of the feed, and this can be done when OntoServer starts or at any time by manual request, or can be automated using OntoServer's API. It can even be configured to occur on a schedule. OntoServer can be configured with multiple upstream syndication feeds, not just one, and specified with the atom.syndication.feedLocation property by an administrator. If the feed requires authorization, OntoServer can be configured with credentials to use for either basic authentication or OAuth 2 client credentials. Once configured, items can be imported using OntoCommand, which is OntoServer's administration user interface, or via OntoServer's syndication API, which is documented at ontoserver.csiro.au/docs. This screen shows how OntoCommand is used to import content from an upstream syndication feed. Users are required to log into OntoCommand and may then click the syndication option on the left of the screen. If the logged-in user has sufficient authority, they will be shown a list of items in the union of the upstream syndication feeds OntoServer is configured with. When an item is expanded, icons indicate whether the item already exists in the server or not. If the item does not exist and the user has sufficient authority, a button is enabled which, if clicked, will import the item into OntoServer. OntoServer has another configuration item which is designed to import syndication feed content when a server is started or restarted. This is typically used in read-only OntoServer instances designed for using and querying release terminology content, as opposed to a read-write OntoServer instance, which is aimed primarily at content authoring. Multiple preload URLs can be specified, and when the preload process is triggered, OntoServer will import the union of the entries in the configured feeds. If the instance already contains items in the feed, they will be skipped. This process may also be re-triggered on a running OntoServer instance without restarting it. This is particularly useful if the content of the configured preload feed or feeds has changed so that the new content in these feeds can be pulled into the OntoServer instance without restarting it. The preload process can also be scheduled using a cron-style syntax to occur on a schedule. This is useful if a read-only OntoServer instance is being hosted for applications and users to query and use the terminology, which is connected to a read-write OntoServer instance using a continuous delivery model. The read-only OntoServer instance can be configured to regularly pull newly available content from the read-write server's syndication feed, which can have content promoted to it as it becomes available. Moving on to the process to create indexes for SnowMedCT and Loink. Indexes are only required for SnowMedCT editions and Loink. These indexes are used to support the advanced features specified for these large code systems in the Fire specification. Other code systems are supported by transformation to Fire code system resources. To build indexes, OntoServer requires much more memory than it does to operate as a read-write or read-only server, and the indexing process ties up CPU for some time. Therefore, these indexes are best created and distributed by an authoritative source, such as the publisher of the code system or a central or reputable organization within the ecosystem of OntoServer instances. This saves unnecessary effort for all OntoServer operators to create indexes for the same data. As a result, most OntoServer operators won't need to create binary indexes and will typically import indexes built by others. OntoServer instances running as servers are able to create indexes. This is achieved by interacting with the OntoServer instance using its REST API to upload the source data of the SnowMedCT edition or Loink version and check the status of the indexing process to determine when it is completed. Once completed, then the index can be downloaded from the server. However, using an OntoServer instance to perform this process can be cumbersome. The resources required for the server to perform indexing are expensive and would ideally only be provisioned during the indexing process, and this requires scripts to make multiple REST calls and poll the server's status to complete the process. As an alternative, OntoServer offers an indexing mode using the same Docker image used to run OntoServer. In this mode, OntoServer is passed a series of input parameters, starts, creates the index, and then stops. This is easier to execute on a temporarily provisioned infrastructure in an automated manner. This mode can be executed using a simple command line Docker run command or a Kubernetes job as an example, and is well suited to continuous integration servers and other forms of automation. The input code system must be a zip file conforming to Snowbit International's or Regenstrief's distribution formats, and can be supplied via the file system or over HTTP or HTTPS using authentication if required. For SnowMedCT editions spanning multiple zip files, these zip files can all be specified to the process, which will merge them during execution. There is no need to pre-merge these into a single file. The indexer mode can deliver the resultant binary index as a file on the file system with a location and file name specified by input parameters to enable automation, or it can be configured to push the index directly into an Atomio syndication server if one is being used. If an Atomio syndication server is being used, it is likely the best option, as the index will need to be in a conformant Atom feed to be fed into an OntoServer instance anyway, which is covered next. So next we'll cover importing an index into an OntoServer instance. Obviously, for an index to be useful once it is built, it needs to be imported into an OntoServer instance. OntoServer only imports indexes from configured syndication feeds. An Atomio syndication server provides the simplest solution, as it provides a REST API to upload the index, which the indexer mode of OntoServer integrates to, and a syndication feed which OntoServer instances can use to import the index. Alternatively, if an Atomio instance is not being used, a simple web server can host a handcrafted Atom feed file referencing the index. An example of this format can be found at r4.ontosserver.csro.au/synd/syndication.xml. Either way, once in a feed, the index can be imported into OntoServer using the process to import items from configured syndication feeds described earlier in this presentation. Finally, we'll discuss removing an index. It may be necessary to remove an index from an AutoServer instance for a number of reasons. For example, the instance may have a large number of historical versions of SNOMED CT editions on it, and to reduce its storage requirement, old unnecessary indexes may be removed. It is also possible that an installed index was built from a version of SNOMED CT or LOINC that has since been recalled and needs to be removed to prevent its use. This operation can only currently be performed using AutoServer's administration API, and a bearer token with administration authority will first need to be retrieved from AutoServer's authorization server if one is in use. The delete code system API is documented on autoserver.csiro.au/docs and is a simple REST call specifying the URL and version of the code system index to remove. Hopefully this has provided an overview of the processes used to import content into AutoServer using its syndication capabilities, and an understanding of the indexing process and how to manage indexes in an AutoServer instance. For further details, please consult the documentation for these features. If you have trouble or further questions, please contact us at autoserversupport@csiro.au. Thanks for listening.